The universe expands, yet the truth remains, still within.
The universe may be far stranger than we think. What if the universe is not the way we believe it is? For centuries, humanity has tried to understand reality by observing the world around us. We built theories, developed mathematics, and created powerful instruments capable of looking deeper into space than ever before. Each generation of scientists believed that we were getting closer to understanding the true nature of the cosmos. Yet something remarkable happened as physics advanced. Instead of making reality simpler, every new discovery revealed that the universe is far stranger and more mysterious than anyone previously imagined. The world that we experience in everyday life feels stable and predictable. Objects appear solid. Time seems to flow steadily forward, and space looks like an empty stage where events take place. For a long time, scientists believed that these familiar experiences reflected the fundamental structure of reality. According to classical physics, the universe was like a giant machine governed by clear and deterministic laws. If you knew the position and motion of every particle in the universe, you could theoretically predict the future forever. But the 20th century completely transformed this picture when physicists began exploring the microscopic world of atoms and subatomic particles. They discovered that reality behaves in ways that defy common sense. Instead of acting like tiny solid objects, particles behave like waves of probability. An electron, for example, does not exist in a single position until it is measured. Instead, it exists in a spread-out range of possibilities known as a quantum wave function. Only when an observation occurs does the particle appear to take on a definite position. This strange phenomenon is called quantum superposition. Experiments have repeatedly confirmed that particles can exist in multiple possible states simultaneously. Even more surprising, two particles can become connected through a phenomenon called quantum entanglement. When particles are entangled, measuring one instantly affects the state of the other, even if they are separated by enormous distances. Einstein famously referred to this behavior as spooky action at a distance. Today, entanglement has been demonstrated in laboratories around the world and forms the basis of emerging technologies such as quantum computing and quantum communication. While quantum mechanics revealed the strange behavior of the microscopic world, another scientific revolution was taking place at cosmic scales. Albert Einstein's theory of relativity showed that space and time are not fixed and absolute. Instead, they form a dynamic structure known as space-time that can bend and stretch under the influence of mass and energy. Massive objects, such as stars and black holes, distort the geometry of space-time around them. What we perceive as gravity is actually the motion of objects following curved paths through this distorted space-time. Even time itself is affected by gravity. Clocks placed near massive objects tick more slowly than clocks far away. Astronauts traveling at extremely high speeds experience time differently than people on Earth. These effects are not just theoretical ideas. They have been confirmed through precise measurements and must even be taken into account by GPS satellites in orbit around our planet. Yet relativity and quantum mechanics describe reality in very different ways. And one of the greatest challenges in modern physics is finding a theory that unifies them. But perhaps the most astonishing discoveries about the universe have come from astronomy. When scientists studied the motion of galaxies, they found evidence that most of the matter in the universe cannot be seen. Stars orbit galaxies far too quickly to be held together by visible matter alone. Something else must be providing additional gravitational pull. This invisible substance has been named dark matter. Although it cannot be observed directly, dark matter appears to surround galaxies in vast halos, shaping the large-scale structure of the cosmos. Current estimates suggest that dark matter accounts for roughly 85% of all matter in the universe. Yet we still do not know what it is made of. Even more mysterious is dark energy. In 1998, astronomers studying distant, exploding stars discovered that the expansion of the universe is accelerating. Galaxies are not only moving away from each other, they are doing so faster over time. Something is pushing space itself to expand. Scientists call this unknown force dark energy. Dark energy may account for nearly 70% of the total energy content of the universe. This means that everything we can see, all stars, planets, and galaxies, represents only a tiny fraction of reality. In other words, about 95% of the universe is composed of things we do not fully understand. Black holes add yet another layer of mystery. When massive stars collapse at the end of their lives, they can form black holes, regions of space where gravity becomes so strong that nothing can escape. Not even light can leave once it crosses a boundary, known as the event horizon. For many years, scientists believed that anything entering a black hole would be lost forever. But in the 1970s, physicist Stephen Hawking discovered that black holes may slowly emit radiation due to quantum effects near the event horizon. Over incredibly long periods of time, black holes could gradually evaporate. This discovery created one of the deepest puzzles in physics, the black hole information paradox. According to quantum theory, information cannot be destroyed. Yet if a black hole evaporates completely, it appears that the information about everything that fell into it would vanish. Solving this paradox may require a completely new understanding of space, time, and quantum mechanics. And perhaps the most fascinating realization of all, is that science does not eliminate mystery, it reveals it. Every new discovery answers some questions, but raises new ones. The deeper we explore the universe, the more we realize how much remains unknown. The universe is not only vast in size, it is vast in complexity, and the journey to understand it has only just begun. Still, within